Hi, this is the cdio lecture. This connects to the previous Things, Meaning, and Value, Truth, Beauty, Goodness lectures. It's capturing all the goodness. It's pursuing the beehive. It's thousands of engineers working together on one big project, finding the patterns that repeat over and over again in small projects. Looking at what goes wrong, giving what goes wrong a name, trying to plan so that that particular thing doesn't go wrong in future projects. This is the culmination of all of that information. Defining roles within a group, describing how to orient yourself so you become an entrepreneur. All these things are part of value and goodness. What do all these engineering design systems have in common? There's sort of a flow chart of how a company's organizing itself or a school's organizing itself to go through a project. It's what's valuable. Everybody's in the same rhythm. Everybody's knows what the next step is. And no two of these are identical. There is no ideal. It's customized to the project. They seem to be unique to whatever the company's producing. In general, all of these flow charts are called project management, and it's what a lot of senior engineers have opinions about. So the CDIO initiative came out of MIT, out of the aerospace department. Aerospace involves lots of engineers and has to get things right the first time. There's not a lot of room for failure. There are a lot of one-off, unique designs. It sort of is like ABET. ABET is in Baltimore. It is an organization that goes around and accredits engineering programs at four-year colleges. So University of Maryland will be ABET accredited. UMBC will be ABET accredited. And they have to be filling out paperwork, and teams from ABET come in and audit the college to make sure it's still worthy of the ABET accreditation. CDIO serves as that for the world now. It stands for Conceive, Design, Implement, and Operate. And it's focusing on documenting all those disaster analysis, what should have happened, the retrospective, looking back, seeing and giving names to the problems that were evolving that weren't quite recognized at that time. Organizing all that stuff into these 4 words: conceive, design, implement, and operate. It's called the CDIO initiative. The syllabus is this collection of all these things, and it's in its 2.0 version. It's being expanded. This is what you're going to read through for your assignment. So what we're going to do next is go through the conceive, the design, the implement, and the operate stages. Conceive could be called planning. It's basically focused on the ideas, the conception of the project. What is the problem statement? Refining, revising the problem statement. What are the requirements? Do you have the requirements right? Go back, talk to the customer, talk to the client. Will the client sign off on the problem statements? Does the client have an idea of what the customers really want and really need? Do we understand what they're talking about as engineers? So it's clearing all that stuff up. We spend a lot of time in these V-Link projects trying to get through this conceive process, and it's difficult because we have multiple clients. Our client is V-Link, but it's a group of people, and they sometimes disagree and sometimes tell us totally different things. So this is the conception part of a project. It's the most difficult. It feels like you're not getting anything done because you're not doing anything in the real world. That's why it's frustrating. Design is where you actually do something. You draw pictures, you create documents, and they're checked by other engineers. And you make prototypes, you make little models of them. You simulate it in software just to get an idea, is it going to work? You do some prototype building and test those prototypes. Sometimes engineering companies outsource this design. On the internet it's called crowdsourcing. Often companies bring in outside consultants to bring in a totally different idea or totally different perspective. It results in documents. Often, as an engineer, you start at the design stage. The conception's already been done by other people. Okay, so we've done the designing, we've done the conceiving, and we're now at the implement stage. This is where you actually do things. This is where you build it, you test it. You build it, and you verify that it's going to work. You get it validated by different people. You get it certified by the various government organizations. Implementing means different things on different projects. So, for example, at Goddard, where only one's going to be built, it means getting it to work. In larger projects, the first prototype is built at the design stage, not at the implement stage. And implement means getting the manufacturing process to work, the assembly lines to work, getting the conveyor belts and getting into the supply chain. For the purposes of a college course, implement basically means getting the design to work, to get a demonstration to work. There are many designs that can't be manufactured. The design engineer has to be brought back during the manufacturing process, and whatever tricky things they were doing to get the prototype working at the design stage now has to be captured and implemented in the manufacturing system. The handoff from a design to implement in the civil engineering world is a handoff of design documents, and two engineering firms can't both design and implement. So the implement is the building of it. Help desks have to be set up. Frequently asked questions have to be created and modified. Problems and practicing rolling it out have to be done. The implement stage is sending out teams of engineers to 600 sites, checking out, getting the servers installed, getting the 20 to the 100 computers attached to those servers. That's the implement phase. Rolling it out, testing the rollout. Is it working at that branch office? The operate stage, the last one, the O, could be called manage. And this is where the bulk of the engineering is done. You know, if you look at a triangle, at the top of the triangle is where the conceive is done by a few engineers. The design is a bigger group. The implement's even a bigger group. But the operate group's the bottom of the triangle, and it involves sales engineers, quality engineers, field engineers, support engineers, service engineers. They're the people out there on the front line next to the customer. Now remember, the customer is also an engineer. So you're running around a plant like this picture right here, looking at those big blue things. They look like turbines and generators in a electric utility company, burning natural gas or something like that. That's what it looks like to me. And that's your first job as an engineer often in a big company, is they just send you around and say, hey, look at all the problems we're having. Get some ideas, improvement ideas, conceive of them. We want you're fresh out of school with a brand new set of ideas. Help us out. In terms of a engineering class project, operation means other students and instructors can operate or demonstrate the device. Projects fail because they take up too much space, because they sort of fall apart. Nobody can explain what they're doing. It's a mystery what that box is. Somebody developed it, but nobody else around here understands it. They'll just throw it away and start a new project and make a new one. You can't improve things that you don't know and nobody else knows anything about. So operation is looking at the world as it was initially designed and how it's evolved as things have broken and been fixed and broken and been fixed. That's conception. So cdio organizes project documentation. What was the conceive stage? What happened during the conceive stage? That might have been done by a previous team, but you need to capture that in your design document, your cdio document. You want your cdio document to be the latest version, the latest and greatest version of the entire project of its history here at Howard Community College. So we're going to be talking more about this coming up.